Imagine a nation's most advanced weapon, designed to dominate the oceans, systematically failing in ways so bizarre that mathematics itself seemed to conspire against its users. In the heart of the Pacific, in 1943, American torpedoes, symbols of naval power, not only missed their targets but plunged to depths where no enemy could be hit. This transformed the expectation of victory into an abyssal frustration. This is not a story of conventional bravery. Instead, it is the saga of how the most humiliating technological failure forced a tactical revolution. It created unlikely heroes and desperate strategies that would redefine warfare, not by what worked, but by what persistently failed. The salty scent of the tropical night mingled with diesel as darkness swallowed the small vessels. Each one carried the hope and despair of a nation at war. This script will reveal how the catastrophic failure of the PT-109's Mark 8 torpedoes, commanded by young Lieutenant John F. Kennedy, was not merely a setback. It was a catalyst for a radical transformation in American naval doctrine. It proved that the deepest innovation often arises from the necessity imposed by failure. The disturbing truth that emerged from the depths of the Blackett Strait in August of 1943 challenged all naval logic and redefined the very essence of war at sea. Lieutenant John F. Kennedy, a young officer with an unknown future, observed through his binoculars a scene that repeated with alarming frequency. Another Mark 8 torpedo, launched with precision and hope, disappeared into the dark waters without the expected explosion, without the flash of light that would signal a devastating hit. This was the fifth consecutive failure that week, a distressing pattern spreading throughout the entire PT boat fleet in the South Pacific. The torpedoes, theoretically calibrated to run at a depth of 10 feet, stubbornly plunged to 25 to 30 feet. They passed harmlessly beneath the hulls of Japanese supply ships. The mathematics were cruelly simple. Boats with a draft of only 6 to 8 feet were impossible targets for torpedoes running 3 times deeper. What should have been an easy and decisive hunt turned into an exercise in frustration and danger. Confidential reports from the time reveal that 73% of the Mark 8 torpedoes fired by PT boats failed to hit shallow draft targets. This created an operational crisis that threatened the entire interdiction strategy in the Pacific. The ineffectiveness of the primary weapon undermined the morale and effectiveness of the crews. The discovery of the torpedo's true running depth did not come from sophisticated engineering tests. Instead, it came from an unexpected and grim source: Australian divers. These brave men recovered unexploded Mark 8 torpedoes from the bottom of Tulagi Harbor. This revealed a mechanical flaw that had been ignored or misunderstood. Precise measurements confirmed what the crews already suspected. The torpedoes consistently ran 15 to 20 feet deeper than their theoretical settings. The depth control mechanism, based on hydrostatic pressure, was incorrectly calibrated from manufacturing. This was a fundamental error with catastrophic consequences. Each torpedo cost $10,000, equivalent to $150,000 in current values. Hundreds were wasted monthly due to these failures. Robert Kelly, commander of the PT Boat Division, faced a deadly mathematical dilemma. Continue using ineffective torpedoes, risking lives and resources, or develop alternative tactics that would place his vessels in extreme danger. The pressure from high command was relentless. Japanese supply lines needed to be cut, regardless of technical limitations. Kennedy and his crew, driven by frustration and the need to understand their weapon's failure, meticulously documented each torpedo launch. They created an unofficial database that revealed disturbing and consistent patterns. In waters less than 40 feet deep, Mark 8 torpedoes often buried themselves in the seabed before detonating. This created useless underwater explosions that only alerted the enemy. When fired at moving targets, the combination of excessive depth and a speed of 46 knots created unpredictable trajectories. This made hitting the target a matter of pure luck, not skill. Torpedoman First Class Edmund Druich, a Navy veteran with 15 years of service, admitted in his personal diary that he had never witnessed such systematic failures. "It's like trying to hit birds by shooting from underground," he wrote. capturing the grim essence of the situation. The PT-109 crew, in a macabre coping mechanism, developed an informal betting system on how many torpedoes would pass under the target. This was a dark way to deal with the operational frustration that defined their nightly missions. The night of August 1st, 1943, marked a radical transformation in the PT-109's approach. Facing a convoy of 4 Japanese ships loaded with ammunition and medical supplies, Kennedy made a decision that violated all established naval protocols. Instead of maintaining the safe distance of 1,000 yards for torpedo launch, he ordered an approach to just 150 yards. This was a distance where small-caliber weapons became mortally effective. The crew, initially shocked by the audacity, reacted with apprehension. Gunner Charles Harris openly questioned, "Sir, this is suicide," Kennedy responded with calculated coolness, echoing everyone's frustration. "Suicide is wasting more torpedoes." The decision represented a complete abandonment of American naval doctrine, which prioritized long-range torpedo attacks over close combat with secondary armament. It was a moment of desperation that forced creativity, a risky gamble against the ineffectiveness of their main weapons. The close-range attack revealed devastating capabilities of PT boats that had been ignored. The PT-109's 37mm cannon, normally considered a defensive armament, easily pierced the wooden hulls of Japanese ships at close range. 50-caliber machine guns, firing incendiary ammunition, created instant fires in fuel and supply loads, transforming enemy ships into floating torches. In 12 minutes of intense combat, Kennedy's crew destroyed 3 of the 4 ships without firing a single torpedo. The 4th Japanese ship, attempting to escape, was pursued and sunk with direct cannon fire at the waterline. Post-action reports documented that the close attack consumed only 847 conventional projectiles. This was in comparison to the $40,000 that 4 Mark 8 torpedoes would have cost. The economic efficiency was impressive, but the cost in human risk remained extremely high, a trade of resources for lives that commanders needed to weigh. The PT-109's contact attack tactic quickly spread throughout the entire PT boat fleet, but with mixed and often tragic results. PT-164, attempting to replicate Kennedy's success, was hit by Japanese defensive fire during a 200-yard approach. This resulted in 4 dead and 6 wounded. PT-157 managed to sink 2 ships, but suffered engine damage that left it adrift for 18 hours in enemy-controlled waters. Statistics compiled by the naval staff showed that close attacks increased the success rate from 27% to 78%. However, they also raised crew casualties by 340%. Commanders faced impossible choices: accept the constant torpedo failures or expose their crews to extreme risks. The war was forcing innovation through operational desperation, a harsh lesson that every tactical advance came with a price. The impact on the Japanese was unexpected and profound. Convoy commanders, accustomed to predictable long-range torpedo attacks, were completely unprepared for PT boats emerging from the darkness at suicidal speeds. Captured documents revealed that Japanese crews began abandoning ships at the first sign of PT boats, even before attacks began. Captain Hiroshi Yamamoto, a veteran of naval transport, wrote in an official report, "The Americans have completely lost their sanity. They attack like kamikazes, but they survive to attack again." The American tactical shift created a terror that spread through Japanese supply lines, multiplying the effectiveness of attacks far beyond the physical damage caused. The mere presence of PT boats, with their new and unpredictable aggression, was enough to disorganize enemy operations. This transformed the war into a psychological game where the perception of threat was as potent as the real threat. Kennedy, with his innovative mind, developed a system of coded light signals. This allowed coordination among multiple PT boats during close-range night attacks. Using naval lanterns modified with red filters, crews could communicate target positions, attack directions, and withdrawal signals without breaking radio silence, a crucial advantage in enemy territory. The system, nicknamed Firefly Code by the crew, allowed coordinated attacks where 3 or 4 PT boats simultaneously surrounded Japanese convoys. During the operation on August 15th, 5 PT boats using Kennedy's tactics destroyed an entire convoy of 8 ships in just 23 minutes, without firing a single torpedo. This tactical innovation, born from technological failure, was completely redefining naval warfare in the Pacific. It transformed PT boats from torpedo platforms into agile and deadly close combat predators. The Japanese response to the new American tactics was swift and lethal. Supply ships began traveling with destroyer escorts, transforming simple interdiction missions into complex naval battles. 25mm anti-aircraft guns were installed on all transport ships, creating deadly fields of fire for approaching PT boats. The Japanese High Command issued specific orders. Destroying American PT boats takes priority over cargo protection. In September of 1943, PT boat losses increased by 280%, forcing a complete re-evaluation of close-range attack tactics. The PT-109 survived this deadly period, but many other vessels were not so fortunate. The war of tactical adaptation had begun, with both sides modifying strategies in response to the opponent's innovations, a relentless cycle of action and reaction. The night of August 2, 1943, brought the definitive test for the new tactics. The PT-109 encountered the Japanese destroyer Amagiri on an interception patrol. Kennedy, following close attack protocols, approached at high speed. However, the destroyer detected the PT boat before it could open fire. The resulting collision split the PT-109 in half, killing 2 crew members instantly and leaving the survivors adrift in enemy-controlled waters. Paradoxically, the accident validated the effectiveness of close-range tactics. The Amagiri was specifically hunting PT boats because close attacks had become so devastating to Japanese supplies. Kennedy and his crew survived by swimming to a nearby island, but the incident demonstrated the extreme risks of the tactics they themselves had pioneered. The thin line between audacity and tragedy was brutally revealed. During the 6 days lost on Plum Pudding Island, Kennedy and his surviving crew obsessively analyzed the events that led to the loss of the PT-109. Engineman Patrick McMahon, severely burned in the explosion, insisted that close attack tactics were fundamentally correct. However, they needed modifications to deal with destroyer escorts. "We need more speed on approach and better withdrawal coordination," he argued amidst improvised medical care, physical pain mixing with the urgency of tactical analysis. Radioman John McGuire proposed the use of diversions, one PT boat attacking frontally while others approached from the flanks. These survival discussions became the basis for refined tactics that would be implemented throughout the entire PT boat fleet. The tragedy was generating tactical innovation that would save hundreds of future lives, transforming adversity into a crucial learning laboratory. Collaboration with native coast watchers, such as Byuku Gasa and Eroni Kumana, added another layer of complexity and effectiveness to the new doctrine. This underscored the importance of local intelligence and terrain knowledge, elements often underestimated in favor of advanced technology. The ability to operate in shallow waters, where enemy destroyers could not follow, gave PT boats a crucial tactical advantage. This fusion of cutting-edge military technology with indigenous knowledge of the local environment created a powerful synergy. It demonstrated that modern warfare is not just a matter of firepower, but also of intelligence, adaptability, and unexpected partnerships. The story of the PT-109 is a reminder that the most effective solutions can come from diverse sources, and that humility to learn from others is a military virtue. In September of 1943, the Navy finally officially recognized that the close attack tactics developed by Kennedy and other PT boat crews were superior to conventional torpedo attacks. Admiral William Bull Halsey issued an official directive redesignating PT boats as fast attack craft instead of torpedo boats. New tactical manuals were distributed, incorporating the lessons learned from close-range attacks. Armament was modified. 37mm cannons received special armor-piercing ammunition. 50 caliber machine guns were equipped with improved night sights, and luminous communication systems were standardized. The failure of the Mark 8 torpedoes had forced a complete evolution in American naval doctrine. PT boats were no longer torpedo platforms that occasionally used guns, but close combat predators that occasionally fired torpedoes. a complete reversal of their original purpose. The tactical transformation had surprising economic consequences, demonstrating that innovation forced by necessity can generate unexpected benefits. Analyses by the War Department showed that close-range attacks cost 85% less than conventional torpedo attacks, while destroying 60% more enemy tonnage. A single successful close-attack mission consumed approximately 1,200 projectiles and fuel, compared to the $45,000 of an equivalent mission using Mark 8 torpedoes. Multiplied across the entire PT boat fleet, annual savings reached $23 million. These resources could be redirected to building new vessels, further strengthening the war effort. Congress, initially skeptical of unconventional tactics, quickly approved additional funding for the expansion of the PT boat fleet. Technological failure had become an economic advantage through forced tactical innovation, a testament to resilience and adaptability in times of crisis. Japanese veterans interviewed after the war revealed the terror that close-range PT boat attacks created. Lieutenant Kenji Nakamura, a survivor of multiple attacks, described the experience with chilling clarity. They emerged from the darkness like furious ghosts, so close we could see the Americans' faces. There was no time for defensive maneuvers, just seconds of terror before the explosions. Japanese staff documents showed that transport crews developed severe disorders, with many refusing to sail in waters where PT boats operated. The effectiveness of American tactics transcended physical damage, creating an operational paralysis that spread throughout the entire Japanese logistical network. Psychological warfare had become an unintentional byproduct of American tactical adaptation, where fear and uncertainty were weapons as potent as steel and gunpowder. The development of specialized ammunition for close attacks represented a technological innovation born from tactical necessity. Naval engineers created 37mm projectiles with tungsten cores that could penetrate up to 3 inches of armor. This was enough to pierce any Japanese ship or transport. Incendiary ammunition for .50 caliber machine guns was reformulated with chemical compounds that burned even when submerged. This ensured that hit ships could not extinguish fires simply by flooding compartments. Miniaturized depth charges were developed for manual deployment, allowing PT boats to destroy stranded or partially sunken vessels. Each innovation responded to specific needs identified during close attacks, creating a cycle of technological evolution driven by real combat experience, where every problem encountered on the battlefield generated an ingenious and lethal solution. The communication network among PT boats evolved into a sophisticated system of tactical coordination that maximized the effectiveness of close attacks. Low-power radio codes allowed communication between vessels without alerting Japanese interceptors, maintaining vital surprise for successful operations. Triangulation navigation systems, using stars and coastal landmarks, allowed precise positioning during night attacks, even in total darkness. Coordinated withdrawal protocols ensured that PT boats could escape quickly after attacks, minimizing exposure to enemy counterattacks. The PT-109, even after its loss, continued to influence these developments through the experiences documented by Kennedy and his crew. The tragedy had become a learning laboratory that benefited the entire fleet, transforming the pain of loss into tactical knowledge that would save countless lives. Statistical analyses compiled in October of 1943 revealed the complete transformation of PT boat effectiveness. Before the adoption of close-range tactics, PT boats destroyed an average of 1.3 Japanese vessels per month, with a crew survival rate of 94%. After the implementation of the new tactics, the average destruction increased to 7.8 vessels per month, while the survival rate dropped to 87%. The trade-off was clear: greater operational effectiveness in exchange for greater personal risk. PT boat commanders unanimously accepted this trade-off, arguing that a quick and decisive war would save more American lives in the long run. The mathematics of war had fundamentally changed. Lethal efficiency outweighed individual preservation, a difficult but necessary decision in the heat of conflict. The story of the PT-109 and the failure of the Mark 8 torpedoes is not just an isolated chapter in naval history. It represents a fundamental turning point in the understanding of warfare. The inability of crucial technology to fulfill its promise forced a complete reevaluation of strategies and the role of small vessels. What began as a series of frustrating failures transformed into a catalyst for innovation. This demonstrated that human adaptability and creativity can overcome material deficiencies. The lesson learned in the waters of the Pacific was that military doctrine cannot be static. It must constantly evolve in response to battlefield realities, even if those realities are dictated by an embarrassing failure. The ability to pivot and innovate under pressure became a hallmark of American resilience. The redefinition of the PT boat's role, from mere torpedo launchers to fast attack craft, had profound implications that extended far beyond World War II. This paradigm shift influenced the design and combat doctrine of future generations of warships. The emphasis on speed, agility, and close combat capability, instead of relying exclusively on a single weapon, shaped the development of patrol and fast attack vessels in navies worldwide. The PT-109 experience demonstrated that versatility and adaptability are as important as raw firepower. The failure of a specific weapon system paved the way for a more comprehensive understanding of how naval forces can be effectively employed in diverse scenarios, from coastal interdiction to amphibious assault operations. The failure of the Mark 8 torpedoes also generated a culture of scrutiny and continuous improvement within the United States Navy. The lesson that even the most advanced technology can have hidden flaws led to more rigorous testing and evaluation processes for new weapons and systems. Transparency about problems, though painful at the time, proved essential for correction and improvement. The PT-109 experience served as a constant reminder that blind trust in technology can be dangerous, and that careful observation and feedback from battlefield crews are invaluable. This mindset of learning and adaptation, born from a crisis, became a pillar for future military development, ensuring that the lessons of Blackett Strait were not forgotten and that similar failures could be avoided or quickly corrected. The story of the PT-109 and the tactical revolution that followed is a testament to human ingenuity under pressure. When the primary tool failed, the men on the ground did not surrender to despair, but sought creative and dangerous solutions. Kennedy's decision to approach within 150 yards, defying established doctrine, was an act of desperation that transformed into a stroke of tactical genius. This ability to improvise and think outside the box, to turn a weakness into a strength, is a defining characteristic of leadership in times of crisis. The story is not just about torpedoes and boats, but about the ability of individuals and teams to adapt and innovate when faced with seemingly insurmountable adversities, rewriting the rules of naval combat with courage and intelligence. Collaboration with native coast watchers such as Biuku Gasa and Ironi Kumana added another layer of complexity and effectiveness to the new doctrine. This underscored the importance of local intelligence and terrain knowledge, elements often underestimated in favor of advanced technology. The ability to operate in shallow waters, where enemy destroyers could not follow, gave PT boats a crucial tactical advantage. This fusion of cutting-edge military technology with indigenous knowledge of the local environment created a powerful synergy. It demonstrated that modern warfare is not just a matter of firepower, but also of intelligence, adaptability, and unexpected partnerships. The story of the PT-109 is a reminder that the most effective solutions can come from diverse sources, and that humility to learn from others is a military virtue. The audacity of close attacks, though risky, had a disproportionate effect on Japanese morale. The image of PT boats emerging from the darkness, with their machine guns spitting fire, and their cannons piercing hulls, created an aura of invincibility that terrified enemy crews. Captain Yamamoto, in his report, captured the essence of this terror, describing the Americans as kamikazes who survived to attack again. This perception, even if exaggerated, was a powerful weapon in itself. War is fought as much in the mind as on the battlefield, and the ability to instill fear and disorganization in the enemy can be as decisive as physical destruction. The story of the PT-109 illustrates how tactics, when executed with audacity and intelligence, can transcend material limitations and become an overwhelming psychological force. The evolution of communication and coordination among PT boats, exemplified by Kennedy's Firefly Code, was fundamental to the success of the new tactics. The ability to operate together, like a pack of predators, allowed PT boats to surround and overwhelm enemy convoys, maximizing their effectiveness. This tactical coordination, developed under enemy fire, became a model for future operations, highlighting the importance of clear communication and tactical discipline in high-risk environments. The story of the PT-109 is not just about a single boat or a single commander, but about the ability of an entire fleet to learn, adapt, and innovate in response to an existential challenge. The tragedy of the PT-109 ultimately served as a catalyst for systemic improvement. Despite increased risks and higher casualties, the decision to adopt close attack tactics was a cold and necessary calculation. The alternative, continuing to waste resources and lives with ineffective torpedoes, was unsustainable. The Navy accepted the trade-off of greater personal risk for greater operational effectiveness, a decision that reflects the harsh reality of war. The story of the PT-109 is a reminder that, in times of conflict, choices are rarely easy and often demand sacrifices. However, the ability to make these difficult choices and to adapt quickly to changing circumstances is what separates victory from defeat. Lethal efficiency, though costly, became the new standard, ensuring that each mission had a purpose and a tangible impact. The ability to transform a technological failure into a tactical and economic advantage is one of the most powerful lessons from the PT-109 saga. The failure of the Mark 8 torpedoes, which could have been a total disaster, was converted into an engine for innovation. This story resonates with the idea that the greatest advancements often come not from continuous success, but from the need to overcome obstacles and deficiencies. The creativity, courage, and adaptability of the PT boat crews, led by figures like Kennedy, demonstrated that human resilience can transform adversity into opportunity. The war in the Pacific was won not only by American industrial superiority, but by the ability to turn defects into operational virtues, redefining naval combat. The influence of the tactics developed by the PT-109 and other PT boats extended far beyond World War II. The principles of coordinated close-range attack shaped the development of naval tactics during the Korean War, where fast vessels attacked North Korean supply lines. Concepts of psychological warfare through surprise attacks were incorporated into Cold War doctrines. Even the modern tactics of fast attack craft in the United States Navy trace a direct line of descent to the innovations forced by the failure of the Mark 8 torpedoes. Necessity generated innovation that transcended its era, creating lasting tactical principles. What began as a desperate adaptation to faulty equipment became a foundation for future generations of naval warfare, a testament to the human ability to transform challenges into strategic opportunities. Kennedy, reflecting on the experience years later, already as president, observed that some of the greatest innovations are born not from success, but from the need to overcome systematic failures. The PT-109 and its crew discovered that technological limitations could be transformed into tactical advantages through creativity, courage, and constant adaptation. The war in the Pacific was won not only by American industrial superiority, but by the ability to turn defects into operational virtues. In the dark waters where torpedoes consistently failed, a new form of naval warfare was born, prioritizing proximity, speed, and audacity over technology and distance. The failed underwater mathematics had created a tactical revolution that would echo through American naval history, a testament to resilience and an innovative spirit in the face of adversity.